Hey guys, welcome back to another round of chemistry notes. Today we're going to start talking about the atom, and we're going to do this in stations. So this is the video for station 1, which is going to talk about atomic structure. So as we talked about in unit 1, matter is anything that has mass and takes up space. So anything you've ever smelled, touched, tasted, that's all matter. And what we touched on in unit 1 is that all matter is made up of atoms. Well, in this unit, we're really going to expand on that. We're going to talk all about atoms. First, we're going to talk about the structure of the atom. So any atom can be subdivided up into two regions. There is the nucleus, which is a very small, teeny tiny region near the center of an atom. It is incredibly dense, and it has a positive charge. So that's your nucleus, right in the center of your atom. There's also the electron cloud, which is a very large region that surrounds the nucleus. Right, so you've got your teeny tiny nucleus, and then your electron cloud is this huge space around it, taking up all this empty space. It is, as I just said, mostly empty space. And it has a negative charge for reasons that we will talk about in just a second. So those are your two pieces of the atom, nucleus and electron cloud. The atom is composed of three subatomic particles. And if we wanted to split this word up into its pieces, that would be sub and atomic. So atomic just means atoms. And sub means below or under, like a submarine goes under the water. So these are things that are under atoms. They're below atoms. They're even smaller than atoms. So those particles, you've probably heard of them, are protons and neutrons and electrons. And as we've discussed, scientists are very efficient. So sometimes it's too much work to write out the entire word, and we will abbreviate it with symbols. So a proton can be abbreviated as a P, with a plus as a superscript for its positive charge. And neutrons can be an N with a 0 because they have no charge. And electrons will have an E with a negative sign for their negative charge. Your protons and your neutrons are both found in the nucleus. And your electrons are found in that electron cloud we just talked about. Right? That's why it's called the electron cloud. For charges, we have two charged particles and one neutral. So your protons, like we just said, have a +1. This is relative. So a +1 relative charge. Your electrons have a -1 relative charge, and your neutrons are neutral. They have 0 charge. I'm sure that you learned this in middle school, but please don't confuse this N. Don't see N and think, oh, neutrons, that's negative. No, look at the whole word, right? Neutron, for neutral, for 0 charge. For our masses, as we saw a second ago, pretty much all of the mass of the atom is concentrated in the nucleus. And that's because your protons have a mass of 1 AMU. We'll talk about AMU in just a second. Your neutrons have a mass of 1 AMU, so protons and neutrons pretty much the same mass. And then your electrons have a mass essentially of 0. They're not completely 0 because they are matter. They do have mass, but that mass compared to protons and neutrons is like 0.000000187 or something very teeny tiny. So if you were going to round that to the nearest anything, you would just round it to 0. So we say that protons and neutrons both have a mass of 1, and electrons essentially have a mass of 0. All right, so speaking of that AMU that we just measured our mass in, sorry, the table's empty now. We have our AMU, which stands for atomic mass units. So we don't use grams when we're talking about the mass of subatomic particles because it would be a teeny tiny fraction of a gram. It would be scientific notation, 10 to the negative, really big numbers. So we use a different unit, a special unit. One atomic mass unit is about 1/12 the mass of a carbon atom. So sort of arbitrary, but it's what we use. AMU, atomic mass unit. We use it for teeny tiny things like atoms. So a lot of the information about atoms comes from our good old periodic table, which gets its very own unit in Unit 4, but we're just going to talk a little bit about some of the information we can get from it. So first thing you can get is the name, which is right here. The name of an element, so this is silicon, it tells you the identity of an atom, right? Every atom has a unique name. That is its identity. It is not a proper noun. Not a proper noun. Please do not capitalize it in sentences like the ones you write in your lab report. When you're using elements in a sentence, please do not capitalize them. They should be lowercase in your sentences. So that's the first thing we can get from our table. The second is our symbol, which is right here. So the symbol is the shortened element name. Some elements have very long names. The symbols are always very short. It'll either be one letter or two letters. Like here, silicon is 2 letters. It's always going to start with a capital letter. Always, always. If there is a second letter, the second letter will be lowercase. There will not always be a second letter. So for example, carbon is just C and nitrogen is just N and oxygen is just O. But if there is a second letter, like in silicon or in tin or in bromine or in chlorine, the second letter is always lowercase. First is always capital, second is always lowercase. The third thing we can get from our table is the atomic number. That's this whole number up here. It's your atomic number. This, just like the name, tells you the identity of the element, because if you look at your periodic table, no two elements have the same atomic number. It is unique for every single element. It's the same as the number of protons. It tells you, oops, that's an O, tells you the number of protons in any element, and the number of protons is a unique property. Every silicon atom ever has 14 protons. So knowing that, knowing the atomic number or the number of protons tells us the identity. Also, for the time being, for one more unit, the number of protons is going to be the same as the number of electrons. Right, so for this unit, protons and electrons are going to be the same number. This asterisk is because that's only for now. Very soon we'll see that that's not necessarily the case all the time. All right, and the last thing you can learn from your periodic table is the average atomic mass. It's an average, as in add everything up, divide it all together. That's this decimal here. This is your average atomic mass, sometimes just shortened to atomic mass. And again, it's a decimal because it's an average. It is the average mass of all of the elements, isotopes, and we'll learn about isotopes in just a second. Once again, those are in units of AMU, atomic mass units. So quick note, because this is an average that you find on the table, if you want to find the specific mass, the actual mass number of just one single specific atom, take the protons in that atom, the number of protons, and add them to the number of neutrons. And that will give you the mass of just that one atom. When you do station 3, you will talk about calculating average atomic mass, and that'll sort of focus in more on this as well. But mass, like mass number, is a whole number. Generally, it's specific to an atom. And then your average atomic mass is an average of all of the isotopes. So, what's an isotope? They are atoms of the same element that have different, that blank was excessive, different masses. And the only way they can have different masses is if they have, they have to have the same number of protons because they're the same element. So same element means they have to have the same number of protons. These things go together. These two statements mean the same thing. Same element, same protons. But if they have a different mass, and if mass is your protons plus your neutrons, then isotopes with different masses must have different numbers of neutrons. So that's all that's different about them. Same number of protons, same number of electrons, just a different number of neutrons. We have two different ways that we can write our isotopes. All right, two different ways to write these. There's hyphen notation, so named because there is a hyphen in it, right? Hyphen right there. And there is isotope notation, or the nuclide symbol. So hyphen notation is easier to write. It's just a name, and it's mass number. And again, that mass is the protons plus the neutrons. So for example, carbon 12, the name of the element is carbon, and its mass number is 12. So in its nucleus, there are 12 things. Another example would be tin with a mass of 118. So that's just read as tin, 118. Or bromine with a mass of 80. So just bromine 80. So that's the hyphen notation. That's how we write it with just the name and the mass. So that's easier to come up with, and it's easier to write because it's one name and one number, but it's not quite as useful because if you want to know anything specific about carbon or tin, you still need your periodic table to find the atomic number, the number of protons. So the other way you can write this, that's a little bit more useful, a little bit more work, but a little bit more useful, is the nuclide symbol, because that includes just the shortened symbol of the element instead of the full name, and it still has that mass number, but it also includes the atomic number. So you have to pull out a periodic table to write this because you have to go find the atomic number, but once you have it, you don't need your periodic table anymore. So we can take our carbon 12 that we wrote a second ago. The carbon, the name carbon, becomes just the symbol C. This 12 right here moves up here. So the 12 stays. We still have the mass number. And now if you look at your periodic table, if you go find carbon, you will see that the atomic number for carbon is 6, right? You go find the square with carbon in it. At the top of that square, there is a 6. So that's how you can write the nuclide symbol for carbon. If we were going to do this for tin, the symbol for tin is SN. A little weird, but it is what it is. The symbol for tin is SN. The mass number goes on top. The bigger number goes on top. And then if you go look on your periodic table, find the square for tin, it will have the atomic number of 50. So every tin atom ever has 50 protons. And last but not least, our bromine 80 example, we can write our symbol for bromine is Br. The mass number, again, it was 80, so the 80 stays. We'll write that 80 up top. And then go look on your periodic table, find the square for bromine, and the atomic number for bromine is 35. One quick note I want to make. You might be looking at your periodic table and saying, oh, this 12 is right there in my square for carbon, or this 118, that's really similar to my square for tin. They are similar, but they are not the same number. So the 12.01 in your periodic table and this 12, this is not just like rounding that. You're not ever, ever, ever going to round that decimal in your periodic table. These are two different things. So please do not just try to round your periodic table to get your mass number. All right, your mass number is either given to you in the name or you can find it by doing protons plus neutrons. You're never just going to round to get there. All right, so at this point in your book, you've got a little bit of practice. You've got that table that's going to let you fill out the hyphen notation, the isotope notation, mass number, atomic number, protons, neutrons, and electrons. Take a minute, fill in those missing blanks, and when you're ready, unpause the video. All right, so hopefully your table looks like this. Again, I just really want to point this out. Your mass number, if you had to come up with it, you should not have rounded anything from your table. You should have taken your protons and your neutrons and added them together to get this number over here. All right, if you haven't done that second practice problem, go ahead and re-pause the video, fill out that second problem, and when you're ready, unpause it and see how you did. All right, so for our first set, they are both carbon isotopes, right? This is carbon 12, this is carbon 13. So some similarities. They are both carbon. Pretty easy one there. If it is carbon, it has 6 protons. Every carbon atom ever has 6 protons. It also has 6 electrons, at least for the time being. So every carbon atom ever will have 6 protons for right now. Every carbon atom has 6 electrons. These are things that both of these isotopes have in common. Things that are different. The only things that are different between isotopes are the number of neutrons, and that affects your mass number. So here we had 6 neutrons plus 6 protons gave us that mass of 12. Here we had 6 protons plus 7 neutrons to give us a mass of 13. So again, this mass number is a sum. It's not the atomic mass from your periodic table. And then over on the magnesium side, same thing. The element identity, protons and electrons. Whoops, this is a typo that I did not fix. Shame on me. That should be 12 electrons because these should be the same number. Copy paste issue there. It's magnesium. It should have 12 protons. It should have 12 electrons. Since they are isotopes, they're going to have different numbers of neutrons, which gives you different mass numbers. All right, last set. If you haven't already done it, pause the video, and when you're ready to check your answers, go ahead and unpause. All right, so hopefully this is what you ended up with for those last few questions, and this marks the end of Station 1. If you're watching this in class, that means it's just about time to get back together with all of these Station 1 people so that you can compare notes and make sure that you're all on the same page before you go back to your original groups and explain it to each other. So use this time, make sure you are comfortable with it, because in a little bit you are going to be responsible for teaching it to other people. If you have questions, ask the people in your group. If no one in your group can help you, then come to me. And if you're watching this at home, then obviously you don't have a group. You should go ahead and move on to Station 2 and learn about the history of the atom and Coulomb's law. Either way, good luck and have fun.